Hey everybody. I'm going to make another video here just doing a few more of these organic chemistry examples just to kind of talk through the thought process and kind of the questions you should be asking yourself and prompting yourself as well as you go through these. So I've got two drawings that I'm going to name, and then I've got two names that I'm going to draw. So we're going to go ahead and start with this guy here first. All right. So the first thing whenever you are tackling a drawing, whenever you have a drawing and you're going to name it, the first thing I always want you to focus on is what the longest carbon chain is. So you're going to find that trunk of your tree. Remember, every peak and end is a carbon. So if I'm looking at this guy, I'm seeing 1, 2, 3, 4, 5, 6, 7. And then remember, your carbon prefix for that is going to be hept. And remember, you can always have accesses to your cheat sheet or to your notes or anything like that to help you remember some of those words. So since it's 7, I'm going to write down hept. After you've got that, then you're going to look and basically see, is there anything on the structure? So something that I'm noticing is I'm noticing these double lines right here. And remember, that means that there is a double bond. When you have a double bond, it is going to be an alkene. So you've got 3 endings, ane, ene, and ine. So since it's a double bond, we're going to use ene. So I'm going to say heptene on my ending here. The other thing that I'm seeing is this little branch sticking off of it. And this branch happens to just be 1 carbon long. So there's just like 1 ending on it. And so with branches, they can be methyl, ethyl, or propyl. Methyl is the 1 carbon branch. So I'm going to write methyl in front of the name. So my beginning part of this structure is going to be methyl heptene. And like I've mentioned before, that's kind of most of the battle. After that, then you're going to do the numbering. So count one way using one color, and then count the opposite way using the other color. You don't have to use colors, I just like colors. So after you've got your numbers, remember you always want to go for the lowest numbers, but more importantly, you want to give the more important thing the lowest number. So I've got like 2 things on my structure. I have this bond and I have a branch. And if you remember our little phrase, bonds beat branches, that means bonds are more important than branches, which means the bond is going to get a lower number. So looking at the bond here, if I use my green numbers, it's on a 2. And if I use my blue numbers, it's all the way on a 5. And so because of that, I'm going to go with my green numbers. And in fact, let's just get rid of the blue ones so we don't get confused. Because once you pick a color set, you're going to commit to it. So my double bond is on the 2, and then that puts my methyl branch on the 5. So when I'm doing my name here, I'm going to put the 5 in front of the methyl because the methyl branch is on the number 5. And then I'm going to put the 2 in front of the heptene because the double bond was on the 2. So you always put the number by whatever it's talking about. So the final name of this structure is going to be 5-methyl-2-heptene. Let's do another one. So the next one that I've got here looks like this, and this is drawn in a structural format. The previous one was in a skeletal format. This one is structural, so it's got the C's and H's on it. Let me get this guy out of the way really quick. So skeletal is the lines, and the structural is going to be those C's and H's. So you're always going to start the same way, even though this one is structural. You're going to find your trunk. You're going to find the longest carbon chain. So when I'm looking at this, I'm seeing 1, 2, 3, 4, 5 carbons in a row. So I'm going to start off by saying pent, because pent is when you've got 5 carbons in a row. Then I'm going to look and see if there's anything on it. So one of the things I'm noticing is I'm not seeing any double or triple bonds. So I'm not seeing any double or triple lines anywhere. So that must mean this is an alkane. And so alkanes get that ane ending. So that means there's just single bonds. Something I do see sticking off of it though is this. Okay, I've got some extra carbons that are coming off of the branch. And if you see, there's 2 carbons coming off of that main trunk. So that is going to be a branch, and since this one's 2 carbons long, this is going to be an ethyl branch. So I'm just going to start off by saying ethyl pentane, because I've got 2 carbons coming off of it, and then I've got a 5 carbon chain. Once you've got your base name, then you just need to do your numbering. So if I count one way, 1, 2, 3, 4, 5, and then the other way, 1, 2, 3, 4, 5. Both numbers, it's on a 3. So I'm just going to pick 3 for this one. And the thing that I'm numbering is that ethyl branch, so I'm saying where the ethyl branch is. So my final name for this is going to be 3-ethyl pentane. If you're curious, if I were to draw this guy skeletally, the pent would be 1, 2, 3, 4, 5. So that's like my 5 carbons. And then the ethyl branch is on 1, 2, 3, and it'd be sticking up the middle. So that ethyl branch, so this guy here is this guy here. So that's the 2 carbons that are coming off of that. So just to kind of tie all of these different things together. The next 2 that I've got here, we're going to go ahead and focus on drawing. So the first one I'm going to draw here is 1,2-dimethylcyclobutane. Okay, you can do this. So the first thing when I see this name that I notice is cyclo. Okay, and you might remember that cyclo means that it's going to be in a ring. Okay, so it's going to be all connected into a shape. And then I see cyclobute, and bute is the prefix saying there's 4 carbons. So cyclobute means there's 4 carbons in a ring. So a square. 1, 2, 3, 4. Those are my 4 carbons stuck in a ring. Ane means they're all single bonds, so I'm not going to do a double or a triple line anywhere. So that's the cyclobutane part right there, is just the square. And I personally kind of like writing little notes to myself like this just so I can kind of remember what I have done. So now I'm going to look at the 1,2-dimethyl part. So the first thing I see is di, and I remember that di means 2. Methyl, if you remember, are those 1 carbon branches. So they're 1 carbon long and they're branches coming out of them. And since it's dimethyl, there must be 2 of them. So I'm going to draw 2 1 carbon branches somewhere. The question is where, and the answer is always found in these numbers here. So the numbers always tell you where you're going to put this thing. And so if I'm drawing 2 1 carbon branches, I'm drawing them on the first and second carbon. So you might be asking yourself, well, where is the first and second carbon? On a shape like this, you basically decide, because if you can kind of change and rotate this around whichever way you want to, it doesn't really have a beginning or an end like a line does. And so I'm just going to start here and go 1, 2. That's it. So 1,2-cyclobutane. So if you were drawing it like this, notice it's the same shape, right? I didn't change it. That was valid. That's valid. That's valid. Okay, so however you wanted to orient this would work. If you're curious how you do this structurally, because if you notice I did it in the lines, I would still start with my cyclobutane, and I would put my 4 carbons in a box shape like this. Notice I did just single bonds because this is an ane, it's an alkane. And then you've got these 1 carbon branches. So you've got these 1 carbons that are sticking out of that 1 and 2. You add hydrogens to make sure that every carbon has 4 bonds, and then you'd be done. So this is this both skeletally and structurally. All right, here's the last one we're going to do. 2,4-octadiene. Okay. Again, the first thing I want to do is find that trunk. So I'm saying oct in here, so that means 8 carbons. So I'm going to start off by doing that. So 1, 2, 3, 4, 5, 6, 7, 8. 1, 2, 3, 4, 5, 6, 7, 8. Cool, so that's my oct. I'm seeing di in here again, and I know that di means 2. And I'm seeing ine. Remember, we've got alkane, alkene, and alkynes. Alkynes are the triple bonds, okay? And since there's a di in front, there must be 2 triple bonds. That's what the diine's standing for. And again, the question is always where. The numbers always tell you where these guys are going to go. So they're going to be at the 2 and the 4. And so if I look at this, if I make this be my 1 and start counting from this end, 1, 2, I'll put a triple bond right here. 3, 4, I'll put another triple bond right there. If you would have drawn it this way and started counting from the other end, that works, right? Because then you're still going 1, 2. Notice that these are the same shape, and that's why we have to do that weird counting thing back and forth, is because these can flip and change. If I were to draw this structurally, I would still start with my 8 carbons. So 1, 2, 3, 4, 5, 6, 7, 8. I would see my diene again, my 2 triple bonds, and they're going to be at the 2 and the 4. So then I would go 1, 2, and I'd put a triple bond here. And then 3, 4, I'd put a triple bond here. Add hydrogens to make sure that each carbon, go away please, to make sure every carbon has 4 bonds. Notice this one already has 4, that one already has 4, that already has 4, that already has 4. So then I'm just going to tack hydrogens on the end here. So these 2 drawings are the exact same thing, one skeletal, one structural. All right, so these are just some more examples that I worked through just to kind of give you a thought process one more time on how you can tackle some of these different questions. Please do not hesitate to reach out if you want to do some more practice together.